In this tutorial, we'll see how to build your first Streamlit app from scratch. We'll cover basic UI controls, how Streamlit reruns scripts, and common beginner mistakes to avoid. By the end, you'll know exactly how to create a basic working Streamlit app up and running in minutes. To get started with Streamlit, the very first thing we need to do is make sure our virtual environment is activated. Now, of course, before we can activate anything, we need to create a virtual environment in the first place. This is typically done with a simple command in the terminal, where we specify the name of our environment. A common convention is to call it .venviv, and that's the name we'll use here. You can name it something else if you'd like, but .venviv is a pretty standard choice. As you can see here in my Explorer, I already have this virtual environment set up, so I won't be running the command again. But if you don't have one yet, go ahead and create it. It's a quick step, and it'll be ready in no time. Now, there's one more thing to keep in mind, and this is important for Windows users. On Windows, we need to make sure our system allows scripts to run. Otherwise, activating the environment might not work. To do that, we'll open the terminal as an administrator. Just right-click on the Windows Start menu, select Terminal Admin. If you're on Mac or Linux, no need to worry about this step. It's Windows specific. All right, once we've got the administrator terminal open, we can run the command that allows us to execute scripts. That command is set execution policy unrestricted. This basically tells the system it's okay to run scripts on this machine, including the one we'll use to activate our virtual environment. Now let's head back over to Visual Studio Code. To activate the virtual environment, we need to find the folder that contains it. In my case, I named it .venv, but if you used a different name, just go ahead and type in whatever name you chose. Inside that folder, there's a subfolder called scripts, and in there we should see a file named activate. We can use the tab key here to autocomplete, super handy. If we tap tab again, we'll see more options. The one we're looking for is activate.ps1. That's the version for Windows. The other files you might see are for other operating systems. Once we run that script file, our virtual environment is up and running. And now that it's activated, we can install Streamlit. We'll use pip for that. So the command we'll run is pip install Streamlit. All right, now we're ready to start building our very first Streamlit application. The first step is to import Streamlit. The common convention is to import it using the alias st. That's just a shorthand we'll be using throughout. Now, the simplest Streamlit app we can create is one that just displays a title. And the way we do that is by using st.title. We pass a string as the parameter to this function. That string becomes our title. So let's go ahead and set it to learn Streamlit. Once we've added that, let's make sure to save the file. Next, we need to actually run our Streamlit app. To do that, we use the Streamlit run command. This works because Streamlit is already installed in our virtual environment. So we type Streamlit run, followed by the name of the file. In our case, that's learn-streamlit.py. Once we hit enter, we'll see our brand new Streamlit application launch right in the browser. Nice! And of course, we can see the title we chose. So let's say we change Learn Streamlit to Learn Streamlit Fast. We just save the file, then head over to our browser and refresh the web page. And just like that, we'll see the updated title. Super easy, super quick. All right, let's kick things off with something nice and simple. We're going to see how we can add a button to our application. It's really as easy as calling st.button and passing in the text we want to appear on the button. Now, if we go ahead and refresh our web page, we'll see that button right there. And this is where we run into one of the most important concepts to understand when working with Streamlit. Streamlit apps are built around the idea of rerunning. What that means is anytime the user provides some kind of input, like clicking that button, the entire app reruns from top to bottom, starting from the very first line of code. And I want us to really see that in action. So let's bring in the random module, and we'll randomly choose a number. Then, instead of always showing the same title, we'll make our title include the random number we generate. If we refresh the page, we'll notice this number, 95. Now watch what happens when I click the button. We get a different number. And that's because every time the user clicks the button, the whole application runs again, from the very first line of code all the way to the last. That's why a new random number gets picked. This behavior is really important to keep in mind, and we're going to come back to it more than once. So, how exactly can we respond to button clicks? Well, there are basically two main ways. The first one is knowing that when the user clicks the button, the value that comes back from the function changes to true. This is exactly why we can use ST_button as the condition inside an if statement. So I can just say if, and when the user clicks that button, its value becomes true on the next rerun, triggering whatever code comes next. For example, right here, we can use the write command to display some extra text. Let's go ahead and remove that random number we had earlier just to keep things clear. Now, if we refresh the page, we'll see the button appear. And at this point, the value returned from it is false. That's why we're not seeing anything from the write command yet. But the moment we click on the button, the entire app reruns. And this time, the value for st.button becomes true. And that's exactly why we see the message that says the button was clicked. Now, there's another way we can handle button clicks in Streamlit, and that's by using a callback. So right where we define our button, we can pass in an extra parameter. It's called onClick. With that, we can link a function to this event so that whenever the button is clicked, this callback function runs. Let's say we call our function buttonClickedCallback. After that, we need to define what this function actually does. It's just a regular function, and we can put whatever code we want inside. For example, I might add a little message to show that the callback worked. I'll make it really obvious and say something like, "This text comes from the callback." Now, if we refresh the page, at first we'll just see the button. But this time, we're handling clicks in two different ways. First, we still have the default behavior, that part that triggers when the button value changes from false to true. And second, we now have our callback function in action. So when I click the button, we actually see both responses, the one from our callback function and the one from the regular code that follows the button. And here's where we run into another little quirk of Streamlit, something that, at least in my opinion, doesn't feel very intuitive. What happens is that the code inside the callback is actually the very first thing to run during a rerun. Now, we already know that when we click a button in Streamlit, the whole script reruns from top to bottom. But the execution order has a twist. Callbacks get priority. The callback code runs first before anything else. So if we take a look, we'll see that line from the callback, like the one that says button click callback, appears before everything else. And that's because the callback code executes first. Only after that does the rest of the script continue. That's why we end up seeing the button and the additional text after the callback message. Now, this behavior in Streamlit, where the whole script reruns every time the user interacts with it, can sometimes make things feel a little counterintuitive. Let's look at a simple example. Say we want to build a basic app that counts how many times we've clicked a button. Sounds easy, right? So if we go about it in the most straightforward way, we might just create a local variable and try to increase it whenever the button is clicked. And since we're handling button clicks in two spots, one in the callback and the other in the part of the code that checks if the button returns true, we'll go ahead and increase our click count in both places. So first, we bump up the count in the callback, and then we also add the same increment in the regular button logic. After setting all of that up, let's just try displaying how many times the button has been clicked. Seems like it should work, but let's see what actually happens. When I refresh the page, we see that the counter says the button's been clicked 0 times. Then I go ahead and click the button, and right away we hit a snag. The callback can't even access that local variable. So let's go ahead and comment out that part. All right, now we're starting fresh. The count shows 0, and when I click the button, it jumps to 1. So far, so good. But then I click the button again, and it still says 1. I keep clicking, nothing changes. It just stays at 1. What's going on here? Well, it's because every time we click the button, the entire script reruns from the top. And our variable for the click count, it gets redefined on every single run, and it's always initialized with the value 0. Since the button was clicked, the button returns true, and that takes us to the part where we increase the count by 1. But that's it. We go from 0 to 1. On the next click, everything resets again, and we're right back at 0 before adding 1. So no matter how many times we click, the number never goes beyond 1. So what we're starting to see here is that callbacks can sometimes be a little tricky. They don't always give us the flexibility we'd like. But even more importantly, the bigger issue we're running into is that our variable keeps getting redefined and reinitialized every time the script reruns. So how do we get around this and actually achieve the behavior we're aiming for? Well, the answer is something called session state. Instead of defining our click count as just a regular variable, we make it part of the session state object in Streamlit. This is a built-in object that Streamlit provides, and anything we store inside it will stick around throughout the session. That means it won't get reset on every rerun, and we can keep using and updating its value as the user interacts with the app. So, if we want our click count to be part of the session state, what we do is refer to it as st.sessionstate.clickCount. And just like that, click count becomes part of the session state, which means its value will stick around across reruns. But there's a catch. Even though we're now using session state, and that should only initialize our variable once, we're still setting it to 0 every single time the script runs. So we're kind of back where we started. What we need to do is make sure we only set the value of click count to 0 if it hasn't been defined yet. In other words, we want to check first, is click count already in our session state? And only if it isn't, we go ahead and set it to 0. To do that, we use a specific kind of check. Basically, we ask if the key we're looking for is not in session state, and if it's not, then we initialize it. That way, we're making sure this initialization happens just once during the session. And from that point on, the value will persist no matter how many times the script reruns. Of course, every time we use click count, we now have to access it through the session state object. So if we go ahead and refresh the page now, we'll see that at the beginning, the number of clicks is 0, just as expected. And when we click on the button, it now correctly keeps track of how many times we've clicked it. Finally, it works the way we want. And here's another nice bonus. By using session state, we can also access that same variable inside our callback function. So now, in the callback, I'm going to increase the click count as well. And when I click the button, we'll see the counter go up by 2. One increase happens in the callback, and the other one happens later in the script. It's important to remember, though, the callback always runs first, right at the start of the rerun, and the regular logic that follows the button runs after that, once the button is actually displayed. But the key takeaway here is that both of them do run, and both can update the same value, thanks to session state. All right, next up, let's talk about text inputs. These are those little boxes where the user can type something in, like numbers, names, or anything else we want to capture. To create one, we use st.textInput, and we can pass in a string as a parameter, which will be the label shown next to the input box, so the user knows what to enter. Let's go ahead and refresh the page. We should now see a box labeled something like first number. Nice and simple. Now let's add another one, this time for the second number. And there we go, we've got both boxes showing up side by side. The value that comes from each text input is whatever the user types into it. So to keep track of what the user enters, we're going to store those returned values in 2 variables, one for the first number and one for the second. Very much like what we saw earlier with buttons, the initial values of our text inputs are going to be empty strings. So let's use write to display what those starting values look like right after the first run of text input. And sure enough, we see that both inputs are empty. Nothing's been typed in yet. But as soon as we go ahead and enter something into those text boxes, we'll see the updated values appear right away when we use write. So whatever we type in, that's exactly what gets reflected in real time. Now with buttons, we saw that a rerun happens whenever the user clicks on the button. But with text inputs, it's a little different. Here, a rerun happens when the user hits enter. So for example, I can change the value in the box to something like 66, then press enter, and as soon as I do, I can see the value update on the screen. That's because a rerun just happened. There's another way to trigger a rerun too, and that's by making the text input lose focus. And what I mean by that is simply clicking anywhere outside the box. So let's say I change the value again, and then just click somewhere else, maybe on the background or another part of the app, we'll see the value change because once again, a rerun was triggered. Now let's take this and turn our little program into a simple calculator that shows the sum of the two inputs. But before we do the actual calculation, we need to make sure the user has entered something in both boxes. So we'll only continue if both input 1 and input 2 have values, meaning neither of them is empty, and the user has actually typed something into both fields. And if the user did enter values in both boxes, we go ahead and write out the result. Now, of course, since these inputs come in as text, we have to convert them into numbers before we can do any math with them. So let's try it out. Refresh the page, type in a value for the first number, then the second number. And once I click outside the boxes, we can see that the sum is calculated correctly. Input boxes also support callbacks, but working with them can be a little tricky. Let me show you exactly what I mean. So what I'm going to do is attach a callback to both of my text inputs. We do that using the onChange parameter. I'll call the callback function showSum. And of course, we need to define that function as well. So I'm going to take the logic we used earlier, the part where we calculate and display the sum, and move it into this callback. Now, if we refresh the page, everything seems to be working. I can enter a value into the first box, then into the second one, and when I hit enter, or when I click into the other box and it loses focus, I can see the result appear. But if we take a closer look, we'll notice something a bit odd. The result we see is always the result we should have seen on the previous run. It's like the whole thing is delayed by one rerun. So what's going on here? Well, once again, it comes down to how Streamlit handles callbacks. The callback function is actually the very first thing to run during a rerun, and it runs before the new values are even passed into input 1 and input 2. So when we type something into those boxes and trigger a rerun, the callback gets called right away, but it's still working with the old values from before we updated the inputs. That's why we end up seeing the result we expected from the previous input, not the current one. Only after the callback has finished running and displayed its output do input 1 and input 2 actually get their new values. So what's the takeaway here? Callbacks in Streamlit can be useful, but mostly for side effects, things like calling an API, fetching some data, or kicking off a background task. But when it comes to doing direct calculations or updating the UI based on user input, it's usually better to handle that logic outside the callback, where we know we're working with the current values.